Okay, so our new topic is exponential equations. Okay, now the exponential equations, they are actually of two types. So I'm gonna start with type 1. Type 1 is an equation whereby, but it's an exponential equation whereby the exponents are the same. Okay? If the exponents are the same, it therefore means that the bases will be equal. So if a to the power of n is equal to b to the power of n. Now, if you have got an equation like this, right? A to the power of n is equal to b to the power of n. We can therefore conclude that therefore a is equal to b. Okay? If the exponents are the same, okay, as long as they are the same, we can make a conclusion that therefore the values of a and b are equal. Okay? That's the first case. Then the second one, which you are most likely to encounter more often, is the type 2 one. Now, the type 2 one, if, okay, here I'm going to change the variables a little bit. So if you've got a to the power of x being equal to b to the power of, okay, if you've got a to the power of x, if, remember, and we've got a to the power of x is equal to a to the power of y, like this, whereby the exponents are different, but the bases are the same. Okay, you can conclude here that since the bases are the same, it therefore means that x will be equal to y. So this is the most common case that you are going to encounter. The type 1, yes, you might encounter it, but it's not the most common case. The most common one is whereby the bases must be equal, therefore the exponents are going to be equal. Okay, so if the bases are the same, then you can conclude that therefore the exponents are equal. That's the most common case. All right, so let's move on to some examples. Now, when you're solving exponential equations, you have got two goals. Okay, the first one is to make sure that on both sides of the equation, you have one term on the left and one term on the right. Okay, and also the exponent is the same. That's the first case, or the first goal, to make the exponents the same, so that you can conclude that therefore the bases are what? Are equal. So that's the first goal. The second goal always is to make sure that the bases on both sides of the equation are equal. If the bases are equal, then we can conclude that therefore the exponents are equal. So you've got two goals whenever you encounter any exponential equation. But the most common one is the one whereby you make the base on both sides of the equation the same. That's the most common one. Okay? So let's go to some examples. These examples are from your worksheet on exponents. Right. I also want you to be aware that this is the last part of your grade 10 exponents, and it's there in the examination. Okay, it's there in the examination. Right. So let's go to exercise 6 of worksheet. Right. I'm gonna do a few examples. Let's start with number 1. Right? If you have got x to the power of 7 is equal to 2 to the power of 7, like this. Right? If you look at that, this exponential equation, it is exponential because we have we have got this 7 as an exponent, we have got that 7 as an exponent. That's why it's an exponential equation. Okay? Now, because the exponent for x is the same as the exponent for 2, we can therefore conclude here that therefore x is going to be equal to 2. Okay? X will be equal to 2 because the exponents on both sides of that equation are the same. Okay? So that's the simplest example that you can encounter. Okay? You can also have, let's say number 11, whereby you have got x to the power of minus 2 is equal to 1 over 81. Okay? Now, when you have got an exponential equation like this one here, you have to simplify the right-hand side until you create an exponent which is equal to negative 2. Okay? You can also use definition number 2, okay, by converting this x to the power of minus 2 to 1 over x squared. You can do that as well. Okay, but what I'm going to do, I'm going to convert that 81 to an exponent which is equal to 2. So to do that, I write my next step as x to the power of negative 2 is equal to 1 over 9 squared. I hope all of you are aware that 81 is the same as 9 squared. Then if I use definition number 2, just to remind you what definition number 2 says, if x raised to the power of negative n, the answer that you get should be x equal to 1 over, sorry, x to the power of minus n is equal to 1 over x to the power of positive n. So I can write this as x to the power of negative 2 is equal to 9 to the power of negative 2. Okay? Once I make the exponents the same, okay, I can then make a conclusion that therefore the bases are equal, so x will be equal to 9. Okay, I've made the exponents the same. Therefore, this x can only take a value which is equal to 9 for us to have equality in that equation. Okay? Okay, I think I'm done with this part here. Right. Then let's do more examples on type 2. Okay, so these examples were for type 1. Right. Let's move on to exercise 7. Any question before I carry on? Are you all following? Okay, so let's move on to exercise 7. Now, exercise 7, this is where you encounter the type 2 case, which is the most common one, right? So I'll start with number 2. That's 9 squared is equal to 3 to the power of x, like that. You did an equation like this. It's called an exponential equation because the x is an exponent. Okay? The x is an exponent. It is an unknown variable, so we call this an exponential equation. Right? So to solve this equation, you have to make the base the same on both sides of the equation. So your knowledge of time factors is required. So this 9 I can write as 3 squared, all raised to the power of 2 is equal to 3 to the power of x. Okay? I have converted the 9 to 3 squared. Okay? I've converted the 9 to 3 squared. Then the next step is to remove brackets. Okay? If I remove brackets, I'll get 3 to the power of 4 on the left, and on the right, I'll get 3 to the power of x. Once the bases are the same, I can therefore conclude that therefore the exponents are equal. So I can here and say therefore 4 is equal to x, which means x is going to be a 4. Okay? Now exponential equations are very, very important in mathematics because they are used in other topics. Okay? If you don't grasp exponential equations, later when you start doing what are called exponential functions or exponential graphs, you are going to end up having issues there. So you have to know how to solve exponential equations. Okay? And then another example. Another example, I can just choose, say, 1 over 2 to the power of x, which is number 12, is equal to 8, like that. So it's 1 over 2 to the power of x is equal to 8. Okay? Now, this one, the best way would be to use definition number 2 and write 1 over 2 to the power of x as 2 to the power of minus x. And that's equal to the 8 converted to the base of 2, that will be equal to 2 to the power of 3. Okay? I use definition number 2 on the left-hand side, and I converted the 8 to a base of 2. So once you get here, then you can say, therefore, minus x is equal to 3, which means x is going to be equal to negative 3. Okay? So if the bases are the same, the exponents will be equal. Okay? Any question? Before I move on to a more complex example, well, this is basic. This is the easiest part. Okay? If you don't have any questions, let me move on to more complex examples. Right, I'm going to do this question from exercise 13. So we have 4 to the power of 2x is equal to 8 to the power of 3x minus 4. So that's our exponential equation. Now when you see an exponential equation, there's no need for you to be scared. There's no need for your heartbeat to increase because you solve it. Okay? The basic idea, the main one, make the bases the same on both sides of the equation. Once the bases are the same, then you can conclude that therefore the exponents are equal. So here, on the left we've got a base of 4, on the right we've got a base of 8. By now you should know that 4 is 2 squared, 8 is 2 cubed. If I come to your home whilst you're fast asleep, I wake you up and say, tell me, convert 8 to a base of 2. Straight away it must tell me it's 2 cubed. It should get to a point where it becomes natural. Okay, so this becomes 2 squared, all raised to the power of 2x is equal to 2 cubed, all raised to the power of 3x minus 4. Okay, I haven't touched the terms in x. I haven't touched it. All I did here, I converted my basis to prime basis, and that prime base is a 2. The next thing is to remove the brackets. So on the left, 2 times 2x will give us 4x. On the right, okay, on the right, you have to be extremely careful. This 3 multiplies both the 3x and the minus 4. Okay? The exponent on the right, which is outside the brackets, it's a binomial exponent. So the exponent inside the bracket has to be multiplied by both the 3x and the negative 4. Okay? That's very important. Like in the past, I've seen some learners multiplying the 3 inside the bracket with the first term of the binomial exponent. And they forget to multiply that 3 by the negative 4. Okay, so make sure you are aware of it. So on the right hand side, I'm going to have 2 to the power of 9x, because 3 times 3x will give me 9x. 3 times minus 4 will give me a negative 12. Okay? Once you get to this point where the base on the left is equal to the base on the right, you should start smiling. Okay? You start smiling. Okay? Then you can make a conclusion that therefore 4x will be equal to 9x minus 12. Okay? There's no need to be scared. There's no need for an increase in heart rate. Right? Then here, we have got a linear equation now. This is called a linear equation. Okay? A linear equation is an equation that has got x with an exponent which is equal to 1. The exponent of this x is 1, the exponent of that x is a 1. So we call that a linear equation. And you were first taught linear equations in grade 8. Okay? So in my case, if I want to solve this, there are many ways of doing it. Okay? It is your choice to decide how you want to do it. You may take the 9x to the left. You can also take the minus 12 to the left and take the 4x to the right. Eventually, you must get the same result. So it is your choice. I won't tell you that take the 9x to the left or take the minus 12 to the left. It's your choice. For me, for now, I'm going to take the minus 12 to the left and the 4x to the right. The main reason is because I don't want to create a coefficient of x which is negative. Okay? I don't want to create a coefficient of x which is negative. So if I take the minus 12, I'll get positive 12. Take the 4x to the right, I'll get 5x, because 9x minus 4x gives me a 5x. Then divide both sides by 5, which means my x will be equal to 12 over 5. Okay. Any question? Yes?
In some cases,
Can you speak up, please?
in some cases, solve such an equation as multiple and simplify it to not even power to and simply
Simplified what? No, that's not necessary. You see, here, the question will be saying solve for x, right? For you guys, you don't specify what decimal places, right? Now, it's always wise, if from now on you know this, it's always wise to work with common fractions as compared to decimal fractions. So when you solve an equation like this, you get to x equal to 12 over 5. There is no need to convert that to a decimal. There is no need. Because converting to a decimal, you are writing the same value in a different form. But the answer itself does not change. So if I convert this 12 over 5 to a mixed number, it will be 2 and 2 over 5. If I convert it to a decimal, it's going to give me 2,4. 12 over 5 is the same as 2,4. So there's no need to convert this to a decimal. In actual fact, when you're working with exponential equations, avoid decimals. Work with integers and common fractions, period. Okay? Yeah. Don't start thinking about other things. The answers, integers and common fractions. Okay? So we stop here. Let me do one more example. Right? For your homework, I'm going to give you more challenging one. Like 3.9. Yes? Yes. Yes. Okay. So 3.9, 3.9, we have 3 to the power of m plus 3 to the power of m plus 2 is equal to 90. Okay? Right? No need to be scared. We have done questions where you have to factorize. Okay? If you see an addition of exponential terms, you see an addition of exponential terms, it means you have to factorize. You have to create a common factor and factorize. If you see a subtraction sign or a difference of exponential terms, it means you have to identify a common factor and check out that common factor. Okay? Don't start doing anything which is unnecessary, which is crazy. No, there's no need for that. There is addition of two exponential terms, right? This 3 to the power of m and that 3 to the power of m plus 2. So what I'm going to do is I'm going to create the common factor on the left-hand side. Because for me to solve for m here, I need to have a monomial term, which is exponential. At the moment, I've got a binomial on the left-hand side. Okay?
Who does this class belong to? This class belongs to? Yes, this class belongs to D. Cesare.
Okay, Mr. D. Cesare. Anybody else?
Anybody else?
No, he's the main one.
He's the main one, but are there any other teachers?
Yeah, I use it and Dr. Pillay.
Dr. Pillay also.
Okay, thank you. They can hear me, eh? Yes.
Yes.
Thank you. All right. So here, I'm going to rewrite the first term as 3 to the power of m plus. The next term, I'm going to use lower one by moving from the right hand side towards the left hand side. We have done this before when we were factorizing. So if you have x to the power of m times x to the power of n, that's equal to x to the power of m plus n. And we are moving from the right hand side towards the left hand side. Okay, you should remember that. So if I'm to carry on here, I will write 3 to the power of m plus 3 to the power of m times 3 squared is equal to 90. Okay? Are you following that? Yeah. By now, I expect everyone to know what I just did, especially the conversion of 3 to the power of m plus 2 to 3 to the power of m times 3 squared. Okay? At this stage, I expect all of you here to know what I did. Then the next thing, I'm sure you can see that there's a common factor. Okay, so I'm going to take out that common factor, which is 3 to the power of m. So this will be 3 to the power of m times 1 plus 3 squared. This is equal to 90. The objective for this question is to isolate the term which has got the unknown variable, and that term is 3 to the power of m. Okay, I've created the common factor, I've isolated it by factorization, then I can write and say 3 to the power of m times 10 is equal to 90. Because 3 squared is 9, plus 1 get 10. And the next thing is obvious, you divide both sides by 10, and then you end up having 3 to the power of m equal to 9. Fortunately, the 9 can be converted to the base of 3, which is the objective. You are in grade 10, if you are solving an exponential equation, if you can't make the bases the same on both sides, it means something is wrong. For you guys, the only way is to make the bases the same. So this becomes 3 to the power of m is equal to 3 squared. Then you can say, therefore, therefore m is going to be equal to 2. Because here we have the same base, we have the same base there. All right? Does anyone else got any question? If you don't have any question, then I can officially say that